are yet to be submitted quickly so that you are able to get along with the classes. And I'll discuss work energy in powers because that these collisions topics were left. And center of mass that is completed today. So tomorrow I can discuss the assignment from the center of mass entirely so that you all can complete also because I've received very few assignments. I think just one or two maximum. So please try to share those who haven't. See, elastic collision in 1D, this says that two bodies of 5 masses 5 kg and 3 kg moving in the same direction along the same straight line. Along the same straight line means like this. One is moving like this, one is moving like this. Now speeds are different. One speed is 3 meter per second, another is 5 meter per second. Find their velocities after collision means V1 you have to calculate, V2 you have to calculate. M1 is given, see, you have U1 given, you have U2 given. You have M1 given, you have M2 given. For this, I've already told you a big formula. V1 is equal to, use that. You will get V1 and V2s. Second says, okay, I think Louis, you left this question. Second one. Was it you who left it? Anyways, two ball bearings of mass M. Someone out of you had left this question. The two ball bearings of mass M, each moving in opposite direction with equal speeds V, collide head on with each other. Predict the outcome of the collision, assuming it to be perfectly elastic. Perfectly elastic means it's a head on collision, bodies are stuck together. So here, you'll have to use the same formula class. Remember, I discussed a case with you, special case. There was a special case which I discussed with you that M1, if M1 is equal to M2, the velocities just get interchanged. So this is that one only for elastic collision, perfectly elastic collision. Two ball bearings are there of each mass M moving in opposite direction with equal speeds velocity. So here the velocities will actually be interchanged. Put the masses as these two velocities as M, these two velocities as M. Now check. How will you predict the outcome? Best method to predict the outcome is for the prediction, use coefficient of restitution. That's the best. Coefficient of restitution comes 1 if it comes lesser than 1 or if it is negative. Coefficient of restitution will tell you most of the things. Okay, yes. So coefficient of restitution you didn't attempt. I think it was somebody from this batch. I hope now the question is clear. Third says a body of mass m moving with speed v collides elastically head-on with another body of mass m initially at rest. Show that the moving body will come to stop as a result of this collision. This is another special case only. Remember, M is initially at rest, means the one where M we assume that it was a bigger body. It is similar to that case only. And there another body M is coming. This is another body M, this is one body M, this is another body M. Here sizes are not different because it's given in the question, it's not M1, M2. They are identical. Just I'm making you recognize the cases which we have done. See, mass you will put as M only. You will put, this says V, speed is V, initial speed is V. Okay, but its speed is 0. U1 is there, U2 is there, M1 is there, M2 is there. V1 can be calculated, V1 and V2. Now see, it says show that the moving body will come to stop as a result of collision. Look class, M1 is M, V1 we have to find out. U1 is given as V for one body. For second body, M2 is given as still as M. V2 we'll have to calculate while U2 is given as 0. Right, this is what the case is. You use the formula of V1 where these things are sufficient. M1 and U1 are only required. M1 plus M1, M2 and U1 are only required. For V2, only M2, M1 and U2 are required. So you have sufficient data to calculate the equation. Remember we did V1 is equal to M1 to U1 U1 into U2 plus V1 into M1 minus M2 divided by M1 plus M2. This formula for V1. Same you interchange 1 and 2 for the second. So same using that you will calculate. It will show that moving body will come to stop. Means when you will calculate, this will eventually be 0. So that shows that okay, this will come out to be 0. Okay, let me discuss the second one. Then you can write down the few points that we discussed. Yeah, inelastic collision in Monday. Here, I think some of you had a trouble. Yes. Second question, some of you couldn't answer. First, everybody did. Ball dropped. Third, also, I think some of you haven't done. Ball is dropped vertically from a height of 3.6 meters. It how can someone just confirm what all questions I have given from this? Or let's, if there are just four questions, no, we'll discuss all of them. We'll discuss all of these questions. Do one thing, just quickly write down the main points from here.
All of them are there.
Aisha?
All four of them are there.
All of them were there. Okay, anyways, we'll discuss all of them. Do one thing, just quickly write down the basic points from here. Then let me discuss the second assignment. That we'll do in detail. Okay, let me discuss this one. Now, see, this says a railway carriage of mass 9,000 kg moving with a speed of 36 kilometer per hour collides with a stationary carriage of same mass. Okay, so mass is the same 9,000, and speed is given as 36 kilometer per hour. So first we have to convert the speed. See, this will be 36 into 5 by 18, that is 10. 10 meter per second. So it is after the collision, the carriages get coupled and move together. What is their common speed after collision and what type of collision? See, whenever you have a common velocity, what kind of collision we call it? Common speed, common velocity. We have discussed discussed it in the class.
Perfectly inelastic collision.
Yes, very good. Perfectly inelastic collision. So this one is perfectly inelastic collision. Correct. So for perfectly inelastic collision, directly use the formula of m1v1 plus m2v2 divided by m1 plus m2. So that is the answer to this. You can calculate it later. Masses are the same. Both the masses will be the same. Second question says, okay, kinetic energy transfer. What percentage of kinetic energy of a moving particle is transferred to a stationary particle when moving particle strikes with a stationary of mass 9 times equal in mass and 1 by 19th of its mass? See, whenever you have any fraction of kinetic energy, I'll tell you a formula for this. Your answers will come very quickly. Percentage, whenever you have to calculate, okay, percentage of kinetic energy transferred, use this, you will get your answers 100% right. Though you can do it from the scratch also, but you can apply this also. 4m1 m2 m1 plus m2 whole square into 100%. Okay, this is the formula. So first one is 9 times its mass. So m2 will be 9 times the first mass. So you can put it in the formula. This will be 4m1. m2 is 9m1 by m1 plus 9m1 whole square into 100. So that will be 36m1 square. 9 plus, what was it? 4m. No, 9 plus m1. That is 10 m1 whole square into 100 for the percentage. So this will be 100 will be cancelled. That is equal to 36%. Clear?
Yeah, ma'am.
Okay. Second says if masses are identical. See, if masses are identical, this will be 4m square here. If I say masses are identical, this will be 4m square divided by. This will be 2m square into 100. That is 4 by, that will be 4 into 100. I think at that complete 100%. 1 by 19th of mass. 1 by 19th of mass means gas. M2 will be 1 by 19th of M1. Put it in the formula. See what's your answer coming. Tell me also. Solve this third part and tell me. Then third question says, okay, rebound to this height. See, here also I'll tell you one formula for the rebounding, for the coefficient of restitution and the height. You will get the answers very easily in one line. This can be solved using motion under gravity's part also. E is equal to under root h2 by h1. Okay, so this is given as 0.6. Height we have to calculate. H1 is already given to you. So E will be equal to under root. In fact, I'll write this as 0.6 is equal to under root. This is h2 by 2. So 0.36 is equal to h2 by 2. So height will be 0.72 meter. Got it? E is equal to h2 by h1. This formula.
Yes, ma'am.
Okay. Last one says a ball is dropped vertically from a height This also you can use the same thing. E is equal to h2 by h1. See, here both the heights are given. E is missing. For the fourth question, look here. For the fourth question, if you use this, E is equal to under root h2. No, second height is given as 1.6. If I take this as 1.6 by 3.6, that is 4 by 6. That is 2 by 3. 2 by 3 is the value of using this. This is the main formula for this, and this is the formula for the kinetic energy transfer. Clear?
Yes, ma'am.
Others also, Neha, now your doubts are clear. I think you have attempted the assignment. Have you?
Yes, ma'am.
Oh, okay. So, is it fine, Neha?
Yes, yes, ma'am.
Okay, please write it, all of you. Then we will come back to the rotational motion. Class, tell me the answer for the third part also. Yes, 19%, correct. Others also get your answer. Now I think it's 7 p.m. I think we should start with the class now. Answer is correct. 19% should be the answer. Check the calculation. Use the formula. Class, use this formula for kinetic energy. Use this formula for coefficient of restitution with height. You will get your answers in just minutes. Okay, now I'm starting with the class. We were discussing the center of mass conservation. Man and Planck's problem we were discussing, and that was completed. So tell me one thing, could you all write it? Let me just share the screen. Yeah. First, tell me Nabila, Aisha, Neha, Ikra is also there? Yeah, Ikra. Yes. So, could you write it here? Was it completed?
Yes.
Okay, this question was completed. Okay. So we have to start with the conservation of the momentum of center of mass. Now, see, it's a very easy small topics are left in the conservation of the center of mass. Okay. So momentum, when we talk about the center of mass is there, center of mass is moving. So conservation of momentum of the center of mass when we talk about, see, your momentum's first equation, we know that the external force is equal to dp over dt, right? So conservation of momentum of center of mass means the net center of mass will be equal to first center of mass plus second center of mass plus third center of mass plus fourth center of mass, like this. The net momentum of each of the center of mass will be conserved. Now, what's an isolated system? I have discussed this term with you. Can anyone tell me what is an isolated system? With all of you have discussed this term.
Is it when no external forces acting on a system?
Very good, Aisha. No external forces acting on the system. Isolated system means external force is zero. So your dp over dt is also zero. So in an isolated system, there is conservation of momentum. We say momentum is conserved. Now, if I say everything, the same things for the center of mass. If I say all the things for the center of mass, then that's the center conservation of the center of mass is momentum. So there's one question in your NCRT, very easy question. This says that if the child jumps off the car towards right with a velocity u, he has jumped off with a velocity u. With respect to the ground, find the velocity of the car after the jump. See, let's say the velocity is some v. Momentum will be conserved because no external force is acting. External force acting is zero. Hence, no external, since no external force is acting, we can say momentum is conserved. Okay, initial momentum is equal to final momentum. So initial momentum means momentum of the child. That is mass into initial velocity. Final momentum will be mass into the final velocity of the car because momentum has been conserved. So this acts like a system. So simple. From here, V will be equal to mu divided by. Okay, I have to differentiate. See, it's not written clearly. Actually, the mass of the car is capital M. This is a capital M. So otherwise, this will look exactly the same. This car is capital M, so capital M will come here. Actually, this question came exactly same question came once in the entrance also. So capital M will come. This is the speed. Clear? Easy? Fine by all of you?
Can you explain that question again?
Which one, Aisha?
This one.
This one? See, a child is jumping who has a mass m with an initial velocity u. The car is present, car, whatever is there, is present with a mass capital M with a speed. We have assumed the speed is v and we have to find its speed. Because no external force is acting, whatever would be the center of mass, that will be conserved. The momentum of the center of mass will be conserved. Momentum will still be m into u. And for the car also, it will be m into u means m into v. So both of them will be equal initial and final. Not exactly initial and final. The momentum of the car plus the momentum of the child. Momentum of the car and momentum of the child. Not the initial and final, they will be the same. So mu is equal to mv. Question said, what is the value of this v? So we just calculated. Now got it?
Yeah, ma'am. Thank you.
All right. Write it. Now we'll come to the rotational motion part. This was all about the translational related. Now rotational will come. First write it. No, not yes.
Done, mom.
Okay. Now, C class. Talking about the dynamics of circular motion, let's first discuss the equations. Then we'll come to the moment of inertia. Yeah, these equations first, let us discuss. Okay, the way we have discussed the kinematics equation, these are exactly the same. So this won't take much time, but these are very important. Before we begin, yes, somebody tell me the equations. Equations of uniformly accelerated motion. Yeah, Nabila, you tell all the three equations.
Um, 2as
What, Nabila?
like v square minus u square equal to 2as.
Square minus u square is equal to 2a, correct?
Um, v equal to ut plus half at square.
S is equal to ut
Sorry.
plus half at square. Yes. V is equal to 1 is left.
Um,
Yes, Nabila.
u plus 80.
U plus 80. Don't forget these. You have the exam coming. That's why I asked you. Okay. See, just remember these main equations which you have already studied previously and write their analogs. So the new equations you don't have to remember, you just have to replace it with their analogs. Let's say S is the displacement. Theta will be the angular displacement. S is the linear displacement. Theta will be the angular displacement. U is the initial angular velocity. U is the initial velocity. Omega naught is the initial angular velocity. V is the final linear velocity. That is written as omega, which is final angular velocity. Then you have A as the acceleration, which is alpha. Angular acceleration we have done, which is alpha. A is our linear acceleration. So you just write their rotational analogs and you place it in the same equations. You will get everything as it is. In the sense, if I take this, the first equation will be V is equal to omega is equal to omega naught plus alpha t. This is what you have to remember. Second, theta is equal to omega naught t plus half alpha t square. Third is omega square minus omega naught square is equal to 2 alpha theta. These are the three equations. We'll be deriving each of them and then we'll practice numerical theorem. First, copy down this page, all of you. Okay, if completed, then let's move on. I hope others have also written. See, let's see the derivation. For the first equation, the alpha is equal to d omega over dt. All these things we are already done with in circular motion. That's why in laws of motion, when the chapter was done, we did specifically the whole topic of circular motion. So alpha is equal to d omega over dt. This is what we have already covered. Now from here, d omega will be equal to alpha dt, integrating it from some initial value omega naught to a final value omega. Fine.
Yes.
And here this is time. So this will be integrated from initially 0 to some t. Okay, now see, integral will give you omega, values from omega naught to omega is equal to alpha will be taken out, t from 0 to t will be left. Omega minus omega naught is equal to alpha, t minus 0. So omega minus omega naught is equal to alpha t. Omega is equal to omega naught plus alpha t. That's the first equation. Second equation, see, omega, we'll start with, see, d theta is equal to d omega over dt. So from here, if you shift this, d theta dt will be equal to d omega. Here, if I just shift this d theta, sorry, I've written it opposite. D omega is equal to d theta over dt. So if we again shift it, d theta will be equal to d omega dt. Now see, here in fact you replace this omega d also because you are calculating omega. So when we cross multiply, the theta will be from 0 to some theta initial and time will be from 0 to t. See, we already know for omega, omega is equal to omega naught plus alpha t. We'll put it here. So d theta, in fact, we'll solve this side as well. Theta will be d theta will be theta from 0 to some value theta, while this will be omega naught plus alpha t dt, integrating it from 0 to t. So theta minus 0 is equal to omega naught dt, integrating it from 0 to t, plus alpha t dt, integrating it from 0 to t. So theta minus 0 is theta, omega naught taken out. T is there from 0 to t plus alpha. This is t square divided by 2 from 0 to t. If we get our answer, theta is equal to omega naught t minus 0 plus alpha by 2, t square minus 0 square. That's the equation. Theta is equal to omega naught t plus half alpha t square. The second equation. Last is, let's say, omega square minus omega naught square is equal to 2 alpha theta. This is what we have to derive. So we know alpha is equal to d omega over dt. All these things we have already done, class. That's why I'm not emphasizing on this one. If we multiply this with d theta by d theta. So what we will get from this, d theta over dt will give us, now you tell me, d theta over dtt will be d theta over dt
D omega.
omega, not d omega, just omega. Because see, on differentiation, you will get the direct value. Correct, very good, Nabila. So alpha will be equal to omega d omega over d theta. Let's shift this. Alpha d theta is equal to omega d omega. Let's put in the limits. Alpha d theta is equal to omega d omega. Integrating from 0 to theta, integrating from omega naught to omega. Okay, so see, from here, this is alpha common, theta is left from 0 to theta. is equal to omega square by 2 from omega naught to omega. This will give us alpha theta minus 0. This will be omega square minus omega naught square by 2. So we get omega square minus omega naught square is equal to 2 alpha theta. That's the third equation. Are all the derivations clear, class?
Yes, ma'am.
Okay, great. Then write it and then we'll practice numericals based on this. The next topic will be different. Write it. We have to do torque after this. Okay, Aisha, you come back.
Thank you, ma'am.
Okay. See, let's start practicing some questions. It's completed. This is an application of a constant torque. See, torque means the rotational force. We'll be discussing torque in this chapter only. So, an application of a constant torque, a wheel is turned from rest. From rest means initial angular velocity is 0 through 400 radian. Theta is 400 radian in 10 seconds is equal to 10 seconds. Find angular acceleration and angular velocity after 20 seconds. After 20 seconds, you have to calculate angular acceleration and angular velocity. So basically, the time that you have to use, it is saying, is after 20 seconds, you have to calculate. See, angular acceleration and angular velocity. It's better if we use the equations. Theta is given, omega naught is given, and time is given. It's like now you convert. It's like initial velocity is given, displacement is given, time is given. So which equation we prefer usually? Whenever you have the questions from rotational function, try to incorporate the equation that we've already studied. Okay, so look, initially it is at 0. Theta is 400 radian. That's the displacement. Alpha can be given using the equation theta is equal to omega naught t plus half alpha t square. That can be used. So here theta is 400. This term will be 0. Half alpha is nothing. And that is, this is find angular acceleration and angular velocity after 20. After 20 seconds, this will be after, see, after 20 seconds means total duration is 30. So it's better if I change the value from here after 10 seconds. This is actually after 10 seconds value. So that will be 10 whole square. So 108 alpha will be 8 meter, or not meter, radian per second square. That's the angular acceleration. One more thing is, what's the angular velocity? You can use any equation to calculate angular velocity. See, omega is equal to omega naught plus alpha t. Omega is equal to 0 plus 8 into 10. Omega is equal to 80 radian per second. Now the next question, next set of questions that we are going to practice will be based on this whole concept of rotation and revolution. See, one rotation, Earth spins around its axis. Plus, what's the angle completed? Complete 360 degree. If one revolution is taken, what's the angle completed? Again, complete 360 degree. That's why we say one rotation or one revolution, both are equal to 2 pi radian. Now, many a times you will be given RPM, rotations per minute or revolutions per minute. So how will you convert? If it is given, you multiply whatever value is given. X RPM is there, whatever is there. You multiply X with 2 pi to find out the new value of angular velocity. Remember your one revolution is equal to 2 pi radian, or one rotation is equal to 2 pi radian. So we will be using this in the next question. Now this, okay, or do one thing, write it till here, then let's discuss the next one. Please write it. Okay, let's move further. I think most of you are done. See, this says angular speed of a motor wheel increases from 1200 rpm to 3120 rpm. 1200 rpm means this is the initial angular speed, that is 1200 rotations per minute. I'm writing it as rpm. Finally, omega is 3120 rpm. These are the rotations given. Time is given as 16 seconds. What is the angular acceleration, assuming it to be uniform? Yes, Neha, can you try and tell me the equation for this? One equation. Angular acceleration alpha has to be calculated in the first part. Yes, Neha. Equation?
Alpha, there's no theta given, right?
No.
Okay. Omega minus omega naught divided by time is equal to
Correct. See, simply use the first equation. Omega is equal to omega naught plus alpha t. Right? So alpha will be omega minus omega naught by t. Omega is 3120 minus 1200 divided by 60. So this will be 0 to, yeah. So this will be 0 to 9 and 1. 1920 divided by 16. Calculate the rest. Radian per second square. Second says, how many revolutions does the wheel make during this time? Revolutions means theta. How many revolutions? What is the number of the angle? So theta is missing here. Yes, Nabila, can you tell me an equation for it, where using which we can find out the value of theta? Theta is basically the revolutions, yeah.
The second equation.
And what's the second equation?
Omega naught into time plus alpha t square.
See, S is equal to ut plus half at square. You all know, just convert that. Theta is equal to omega naught t plus half alpha t square. Okay. Nabila, you were correct. So theta will be omega naught is 1200 into t plus half. Alpha we've calculated from here 1920 by 16 into 16 into 16. So this you will have to solve. I'll tell you the values. This is, okay, this is also 19200 plus 19. This is, I'll just tell you, 1620. Okay, this is 1536. Please calculate it yourself also and get the final answer. So this is 065. Okay, that's 434. So these many revolutions. Then what you do, why did I calculate it right now was because see theta, when you write it in revolutions per minute, when it comes. Okay, this is one more thing. This is given in minutes also. Revolutions per minute. So we will not get our answer. I have written it in seconds square, sorry. We will get our answer alpha in minutes per square. Okay, this will be in minutes square. Similarly, this also will not be in the SI form. So what we can do, we can convert this also here. These many revolutions per minute are there. So omega naught can be written as, this is 1200 into 2 pi. Okay, divided by 60. This multiplied by pi by 30. I think that will be better. Because this is not in the SI form, though this is there. I'll rewrite it here as well. So in the SI form, this will be omega will be equal to, look, omega is equal to omega naught is equal to 1200. So whenever you have to convert it into radian per second, multiplied by pi by 30. So that makes it 40 pi initially, and finally is 3120 into pi by 30. So this gets cancelled. This is equal to 1045. This also you can solve to write the values. Okay, this one also. So this will give you the answer in seconds. This is in minutes per square. When you write, it will be in minutes per square. Okay, and it's better if you write it as revolutions per minute square. That will give you a precise answer, because radian also we have not converted. So this is revolutions per minute square. But don't try to answer in this. Try to convert and then only answer. Whenever you have anything, try to convert and answer. So now when you write alpha, this will be 104 pi minus 40 pi divided by 16, which is equal to 64 pi divided by 16. Now you clearly have your answer. So look class, whenever you have the questions in terms of the revolutions per minute, or if you have it in terms of rotations per minute, convert it and then write down the answers. Because see here also, when I did not convert the answer, I wrote it as by mistake radian per second square, so that won't be there. And this will be 4 pi. Now this will be radian per second square. This will be revolutions per minute square. So precise answer should be given in terms of radian per second square, so that there is no difference in the answer. This also I'll write it in the revolutions in the SI format only. Now we already have the value, so we can put it. Theta will be given by omega naught. Omega naught is how much? 40 pi. 40 pi into 16 plus half into 4 pi into 16 whole square. This you can solve later. That will be the answer in radian. So this says how many revolutions does the wheel need during this time. So these many revolutions. This is in radian. What you do in order to calculate the answer in radian, you take this whole value, you divide it by 2 pi, and that will give you the value in revolutions. Means just the reverse of it. Got it? How to write in radian, how to write in revolution for both theta and omega and alpha.
Yeah, ma'am.
Okay, then please write this question as well. Then this I've already discussed. Torque is left. Okay, so this completes with this topic. Write it. So probably tomorrow we'll be able to complete a major portion, and moment of inertia will be left in.
Ma'am, does this question come after the wheel question?
Does it come after this one?
The wheel.
Did you write this one?
No, I took a screenshot.
Okay, take the screenshot then.
Thank you, ma'am. Done. Thank you.